So in this video we discuss the problems on sampling theory. The first type of problem is test of significance of proportions. Let x be the observed number of successes in a sample size of n and mu is equals to n into p be the expected number of success. Let the associated standard normal variate z is defined as z equals to x minus mu by sigma. So this standard normal variate we already studied in the normal distribution. So we use the same normal distribution standard normal variate here. Z is equals to, so that is x is nothing but mean value, that is x bar, minus mu is the mean of n binomial distribution. Here we consider the mean and standard deviation for the binomial distribution, that is mu is n into p and sigma is square root of n into p into q. P is the probability of success, q is the probability of failure, n is the number of trials. So we have one more formula here, the same standard normal variate, that is x bar minus mu by sigma by root n. So for the large population we apply the second formula. For the problems tossing a coin or throwing a die, in this case we apply the first formula. So tossing a coin and throwing a die, there is a chance of getting probability of success and probability of failure, p and q values. So in this case we apply this formula. Suppose while solving the problems, if in the problem they given standard deviation mean value directly for the large population, we consider the second formula. We solve the problems on both the formulas. So just to remember, the coin and a die is thrown. In that case we apply the first one, and for a large population, that is standard deviation and mean is given in the problem, we apply the second formula. Depending on the problem, any one formula we apply. Now, so after finding the z value, so what we are finding means they give some hypothesis. So hypothesis is nothing but the assumptions, they may be true or may not be true. So in the problem they give some hypothesis. We have to either accept the hypothesis or reject the hypothesis depending on the z value. Here two level of significance are there. One is 5% level of significance, another one is 1% level of significance. Sometimes they ask 0.01 or 1%, both are same, 0.05 or 5%, both are same. So they clearly mention in the problem, you have to find the hypothesis either at the 1% level of significance or 5% level of significance. If the 1% level of significance, if the modulus of z value is, if you got less than 2.58, we accept the hypothesis. If the modulus of z is greater than 2.58, we reject the hypothesis. Similarly, if in the 5% level of significance, if the modulus of z is less than 1.96, we accept the hypothesis. If it is greater than 1.96, we reject the hypothesis depending on the problem. If they ask 1% or 5%, if they are not mentioned any level of significance, you can consider any one level of significance. Depending on that, either we accept the hypothesis or reject the hypothesis. So this is the procedure to solve the problems. Now, so we consider the model question paper problem here. So from this topic, in the model question paper, they given two 6 marks question. From the test of significance of proportions, they asked this two 6 marks questions here. So very simple problems. So there is no more calculations are there. Now the first problem is the mean lifetime of a sample of 1000 fluorescent tube lights manufactured by a company is found to be 1570 hours with a standard deviation of 120 hours. Test the hypothesis that the mean life of a lights produced by the company is 1600 hours. At what level of significance we have to test means 0.01, that is 1% level of significance we have to test. So first you understood the question, what they asked, and what is the values they given in this problem. They given the standard deviation and mean. So if the mean and standard deviation directly is given in the problem, we apply the second formula. So I already explained, two formulas are there. So if the standard deviation and mean is given for the large population here, in that case we apply the second formula. Now actually according to the lifetime of a sample of 1000 fluorescent bulbs, the company, what company is saying, the mean lifetime is 1570 hours. But what is the hypothesis we are telling? Hypothesis means what is our assumption is, we are telling that mean life of a light is produced by the company is 1600 hours. Either we have to accept this hypothesis or reject this hypothesis. We have to test that. Now how to solve the problem is, first write the value of n. N is the number of bulbs here, and x bar is the mean value of what the company assumption is, 1570 hours. And what is the standard deviation sigma, that is 120 hours. And what is in the hypothesis, what their assumption is, the lifetime of a light is 1600 hours. This is your mu. X bar is the, what is the assumption of a company, lifetime of a fluorescent bulb, that is x bar, and whatever the value of the assumption hypothesis, we consider that as mu. So always hypothesis, so whatever the value they give in the hypothesis, we consider that mean as mu, and the mean given in the problem as the x bar. So is it clear? Hypothesis value should be always mu, and the given value is your x bar. Now find the value of z, that is x bar minus mu by sigma by root n. X bar is the company manufactured, what is the assumption of a company, that is 1570 hours mean life of 100 fluorescent bulbs. And what is our assumption is, the mean life of 100 fluorescent bulb is 1600. That is mu divided by sigma is 120 divided by root 100, that is minus 30 by 12, that is minus 2.5. Now this is your z value. Now we are finding at 1%, because they clearly mentioned here at 1% level of significance. So 1% level of significance case, we find the modulus of z. Modulus of z is, modulus of minus 2.5 is 2.5. This value either less than or greater than 2.58. So we have conditions here, either it may be less than or greater than. So these are the conditions we apply for every problem. 1% if they asked, you have to see for 2.58. If they ask for the 5%, we compare with 1.96. Now what is the value we got? Modulus of z is 2.5, that is less than 2.58. So less than case we accept the hypothesis. So what is the hypothesis? We can accept that. That is, so we accept the hypothesis. That is, what is a hypothesis? The mean life of a tubes produced by the company may be 1600 hours. If you got here greater than, we reject the hypothesis. So depending on the z value, either you accept the given hypothesis or reject the given hypothesis. So this is the method of solving a problem. So I take the one more problem, similar problem. This is also a model question paper problem. So in the model question paper, they ask the similar problems only. A sample of 100 students is taken from a large population. So whatever the hypothesis we do, we are not doing for entire population. We just consider only sample of the population and we do the assumptions. What is the mean height of a student? So the mean height of actual height is 160 centimeters. The mean height of the student. can it be reasonably regarded that the population, the mean height is 165 centimeters? This is the hypothesis. So what is the mean height of normal 100 students is 160. Suppose if I made an hypothesis that the mean height of a population of 100 students is 165 and the standard deviation is 10 centimeters at 5% level of significance. Is this hypothesis? So what they are telling? Actually the mean height of is 160 they are given, but suppose if I made an hypothesis that it should be a 165. Is this hypothesis is accepted or rejected? We have to verify. We can accept this hypothesis or we reject the hypothesis that mean height is 165. We verify here. Now, so first write what is the value of n, number of students, and write the x bar value, actual mean, and hypothesis mean we consider as mu. Always the actual mean is x bar and the hypothesis mean should be 165 and the standard deviation is 10. Similarly find z, x bar minus mu by sigma by this formula. When we apply this formula is if the mean and standard deviation is clearly given in the problem. So in the next video we solve the problems on a coin or throwing a die. In that case I apply the second formula. Now what is x bar? 160 minus 165 by sigma is standard, that is minus 5. So 5. Now which level of significance they ask? 5% level of significance. So 5% means we have to consider here 5% level of significance. So we have to consider 1.96. Is this a less than? We accept. It is greater than? We reject. So what we got here? Always we have to consider modulus of z, not the value of z here. Modulus of z. We got greater than 1.96. Therefore we reject the hypothesis that. What is the hypothesis we are rejecting? At the end we have to write the conclusion, then only you get the full marks. So we have to write the conclusion that we are rejecting the hypothesis that the mean population of a height of 100 student is 165. So what is the hypothesis? We are rejecting because the value should be the greater than 1.96. So this is a method to solve the first type of problems. Next video we solve the second type of problems.